Hey everyone, welcome back to part 2 of the trig identity worksheet. We're going to cover problems 5 through 8. So if I kind of hop right in, and you can attempt these kind of on your own and see if you can start making some headway and then compare and contrast to what I have here. Again, any ability that I have to do this just comes from having done a number of these problems, so you just need to start working on those as well. And then, you become more comfortable with them over time. So don't get dissuaded if you can't kind of jump to all these same steps. It's just from me seeing a lot of the patterns ahead of time and being able to apply them. But obviously that only comes with having done a bunch of these problems. So in this first situation, I've got this cosine squared y here, which I recognize this entire thing is very similar to this Pythagorean identity, okay, which if I manipulate it to have cosine squared y basically be by itself, I'll get cosine squared y equals 1 minus sine squared y. So I'm going to use this in my equation and just replace cosine squared y with 1 minus sine squared y and see where we get. So this is now 1 minus sine squared y. And then I'm going to continue writing the rest of it. That's another minus sine squared y equals 1 minus 2 sine squared y. If I combine these terms, then I end up with 1 minus 2 sine squared y equals 1 minus 2 sine squared y, which was what I was trying to prove. Good. Problem 6, I'm going to try to set everything to sine and cosine and see where I get. Cosecant squared theta is the same thing as 1 over sine squared theta. Tangent squared theta is sine squared theta over cosine squared theta. Minus 1 equals tangent squared theta. Here I can see that these cross out. So I have 1 over cosine squared theta minus 1 equals tangent squared theta. 1 minus cosine squared theta is the same thing as secant squared theta minus 1. If I'm looking on my little cheat sheet at this point, I should see this as a Pythagorean identity, which again isn't in the exact form that I want right now. I would prefer to try to figure out what secant squared theta minus 1 is. But if I visually look at that and I try to manipulate that expression by subtracting 1 from both sides, I do get that secant squared theta minus 1 is equal to tangent squared theta. So in this next step, I would basically just be applying this Pythagorean identity to say, oh, secant squared theta minus 1 is tangent squared theta. And that's what I was trying to set this equal to. So I didn't need to adjust my right-hand side at all. And I was just able to kind of prove this straight adjustment on the left-hand side. All right, taking a look. Since I just dealt with the secant squared theta minus 1, right? I almost came up with an identity just right here. Secant squared theta minus 1 equals tangent squared theta. I'm going to use that here in order to replace this with tangent squared theta. So this now becomes secant squared theta divided by tangent squared theta equals cosecant squared theta. Instead of having this be divided by tangent squared theta, I'm probably going to switch all this over into cosine and sine on my left-hand side. So that's 1 divided by cosine squared theta, big division, sine squared theta over cosine squared theta. So that's me rewriting tangent as sine over cosine. And I'm still trying to prove that this equals cosecant squared theta. I don't love my stacked fractions, so I will be multiplying by the reciprocal instead. So that's 1 divided by cosine squared theta times the reciprocal of my denominator, which is cosine squared theta over sine squared theta. Still trying to prove that this is cosine squared theta. These are going to cross out. So I have 1 divided by sine squared theta equals cosecant squared theta. And that is basically almost our final true statement. I'm just going to use a reciprocal identity to say that cosecant squared theta equals cosecant squared theta, and then I should be all set and done. Okay, so 1 divided by sine squared theta just turned it into cosecant squared theta. Reciprocal identity in order to get my answer. All right. Looking at my right-hand side, trying to figure out how best to do that. I'm just going to start by changing tangent squared x into sine squared x over cosine squared x times sine squared x. And almost I'm probably noticing already that I wish I had adjusted my right-hand side. So that may be something that I actually look to do at this point. Yeah, I'm just trying to think. I don't know how I would adjust my left in order to get there. So I'm going to adjust actually my right-hand side in this particular case. And the reason that I'm doing that is on the right-hand side, I can see that I can generate some fractions and find some kind of like terms. So that's actually what I'm going to attempt to do. You know, I could scribble this out or just kind of X that strategy off, as in I didn't like that first step. But know that I've kind of scrapped that. And what I'm going to do instead is rewrite my right-hand side. So tangent I'm going to write as sine over cosine. And then sine I'm going to leave like this. And then I'm going to try to get some common denominators out of those. So I need to say, okay, this is left-hand side staying as it was. On the right-hand side, I'm going to multiply that second expression by cosecant squared over cosecant squared. So this becomes sine squared x over cosine squared x minus sine squared x cosine squared x over cosine squared x. So now I'm here. My denominators are the same, so I can actually combine this into a single expression. And what I actually might do also, actually no, let's just write it first. End up being here, divided by cosine squared x. Still trying to prove the left-hand side that it equals this. So on the right, I'm actually going to factor out a sine squared x from my numerator on the right-hand side. So this is now sine squared x times this is going to be 1 minus cosine squared x, all divided by cosine squared x. I'm trying to prove that this equals tangent squared x, sine squared x still. And I can see the following. Sine squared x over cosine squared x is tangent squared x, right? So that's just using a tangent identity. And then I can also see that 1 minus cosine squared x, if I do a Pythagorean identity, is sine squared x. So that's kind of the next two pieces of logic that I'm going to do, and I'm going to write these just down here. So trying to prove tangent squared x equals sine squared x. I'm going to change sine squared x over cosine squared x to tangent squared x. That's my green highlight. And then my purple highlight, 1 minus cosine squared x, well, that is sine squared x. And that ends up being from a Pythagorean identity. So again, I've kind of proven this one. And this one took me kind of fumbling over in the beginning on that first attempt. And that's exactly kind of what I expect you to be doing as well, is making an approach at it and realizing, yeah, that might not kind of get me there. Maybe I want to tackle it a little bit differently. So glad to kind of see that I could demonstrate one of those. And that's what verifying an identity can kind of look like. We'll keep taking a look at some of these other ones on future